Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So here a first question is, what is Docker? Right? First question is, what is Docker? So when we say a Docker, basically it's a container management tool. Okay, it's a container management tool. Now here if I see, there's a three words: container management tool. So three words. So the next question is, what is container? What is container? That's the next question. What is the definition of tool? So if I see the definition of tool, that means saving a cost, saving time and improving the efficiencies. Okay, improving the efficiencies. So this is the definition of tool. That means we got to know, with the help of Docker, we can save cost, we can save time, and we can improve our efficiencies. But for what? In running applications. Okay, in running applications. But how? With the help of container. Now the question is remain same. What is a container? Correct? So we need to know what is a container. Okay, and guys, this is a very important session for all of us. It's a new technology which we have to learn, and going forward, no matter whether you are a dev, QA, operations or whatever role you are performing, you need to know this one, because it's a platform now. Okay, so we all will run applications. We will all run applications in a container. So what is a container? So if I look at the definition, which we are using most of the time, so we say container is a lightweight, okay, lightweight, standalone, complete and independent environment for running app. It's lightweight. So when I say lightweight, that means it's consume less CPU, less storage, something like that, less RAM. Standalone means no dependencies, complete, independent from everything, environment for running app. But we need to deep dive into that, and we need to understand what is a container. So if you really want to understand what is a container, then we need to know how we run any applications. How do we run any applications? So anyone would like to tell me, how do we run any applications? What are the prerequisites we need for running application from start to end?
We need a server for it, first of all.
Okay, so we need a hardware, correct? Hardware which includes CPU, RAM, storage, and then on top of that we need what?
OS.
Operating system. Then on top of that, what we need?
Tomcat, Apache kind of some server.
JDK. On top of that, Tomcat. On top of that, our application. Is that something which we do every day?
Yes.
So yes, this is how we run applications. But we know, today we will discuss little bit in deep. Now in operating system, what we have, so this is application, this is also application, this is also application. So all these three are applications only. Okay, these are applications only. So now the question is, what is there in operating system? Understand that. What is there in operating system? In operating system which allow application to run? That we need to know today. If you really want to know what is container, you need to know this question. What is there in operating system which allow application to run? So guys, if I look at this operating system has kernel, right? Operating system has kernel. Now, do you know what kernel has it? What kernel has it? Anyone? Kernel has library, but this library we call it in kernel name space. Kernel name space. Can we see some images that will be good memory for our definitions? See, kernel namespace. See here. See here, this is a good image. See, Linux namespace, type of namespace, net namespace, mount namespace, PID namespace, user namespace, C group namespace, UTS namespace, and so on. Are you getting my points? So here in Linux we have namespace. Now some of the namespace I would like to mention here. Type. This is the type. You see here, type. One of the namespace is user namespace, which is somewhere here. Another namespace is PID namespace, which is something here. Another namespace is mount namespace, which is here. And one more namespace I need is network namespace. So these are the namespaces. Okay. And we have one more which I am keeping it separate. This is a namespace only, but I am keeping it separate for understanding purpose. That is called C groups, which is here. And we have one more thing in a kernel, and that we have a capabilities. Now you must be wondering, okay, why we are discussing this one? We are discussing this one because we want to know what is there in OS which allow application, this application, this application, this application to run. So guys, if I draw pictorially, probably it will be better. So see here what happens. One applications we want to run. So this is the hardware layer. On top of we have a kernel. We typically call operating system because kernel is having very lightweight libraries, which is namespace. But if you say operating system, that means what happens? They add lots of utilities, graphics, this, that, tools, and then it's become operating system. So understand that. And then on top of that, we think about it. We create one user, don't we? And then top of that, we run one application. Okay? Are you getting my points, guys, here? There's one more user you can create. There's one more user you can create. So you can run one application B and C. So there are 3 users. You can run 3 applications in the same machine. So now this user, this isolation wall, so that user A, can he see the files of user B? Or user B, can he see the files of user A? Guys? If you are a normal user, can you see each other's file system?
No.
No. So this user, this user isolation is created by whom, this namespace. So guys, how many users you can create in one operating system? Anyone has that number? How many operating system you can create in one operating system? Do you have any number?
2.
Only 2? What about other people?
It's a huge number.
So multiple user you can create. There is no limitation as such, right? So you can create so many user. But guys, this process, this applications required the process ID, right? Do you understand the process ID? PID. Understand that, right?
Yes.
So guys, the process ID, every ID generate from the 0, then 1, then 5, 10, 6, 30. This is a kind of model. You know that, have you seen the process table of Linux? PS-EEF. Have you seen it? In Windows also is there. Let me show you. Here, if you go to the task manager, this is the details. Look at this. This is a process PID. Okay. See, starting with 0. Did you understand this? In Windows also, you have a process table. Did you understand this?
Yes.
So each application, see how many applications we are running in my Windows machine. So each application, it required process ID. Why process ID? So using that process ID, they will get CPU allocation, RAM allocation. See here, this is the PID, and here you are getting CPU, and here you are getting memory. Because how this system will come to know which process ID, which software I need to get how much CPU. So they track it through the PID, process ID. If you kill this process ID, this application will not run. You know that, right? Have you've been working on this, correct?
Yes, Rajesh.
So guys, the question is, who will create a process map. That means whenever you run any applications, each application should be having one process ID. This called process map. This called process map. So in the system, how many process map you get it? See how many process map. In a short way, I'll tell you how many 448 can be created PID in this system.
Only one.
Only only one. So that means for process map. Let me close that. This is coming again and again. So how many process map you create? Only one. So guys, here I will draw only one. So guys, here from the kernel, there is one process map has come up, which is shared by all the user. Yes, you're right. This is process map PID, and this user got created from the user namespace, which is allowed multiple. You see here, multiple. You only said. Now, guys, I would like to show you mount. Okay, mount. So in the mount, how many mounts you get it? Mounts, when I say typically the storage, how many mounts you get it? Okay, so if I go and show you my computer, how many C drive you can see here? How many C drive you can see here?
One.
Have you seen 2 C drive ever?
No.
Have you seen in Linux? Have you seen 2 OPT, 2 TMP, 2 SBIN? Have you seen it? No?
No.
So
No.
in that case, how many mount get initialized here? How many mount? This mount, guys. Mount storage, storage, mount. This is called file system. So how many you got it? One. So this is a file system, guys. Okay, this is a file system. So you in operating system kernel, it mount only one file system. So see here, I got only one mount system. Now this will be shared by all the user. So this is MNT mount. Now guys, here this application is running. So see here, we were discussing what are the things in OS which allowed to run application. So his application need PID, it gets from here. Application need mount, storage, file system, it gets from here. And all this come from where? Here. Let me change the color. It's come from here. This is kernel is empowering this. Kernel is empowering this user also. Okay. Now this application need to access from outside the host. Then what we need? Guys, then what we need?
Network setup.
So guys, how many networks we get initialized in the each operating system? One. Have you seen that? I'll put it in a simple way. Have you run this application on 80 port and the same application, a different application by same user or different user, can you also run on 80 port? Tell me.
Yes.
Can you run it?
We can't run it on 80 again.
Yeah, 80 port you cannot run. That means how many network get initialized in the one host? One. So guys, this network come from the network namespace. So now these are the important characteristics component which is needed. So what happened? See here. I ask what is there in OS which allow applications to run. So to run any application, you need one user space. Without user, can you run any application? No. You have to become one person. Apache, Jenkins, MySQL, you. So you have to become someone to run application. So that way it create isolation. and then you need one PID table, one mount, one net. But what is happening in this operating system? Thus all users share the this is shared between all the user. This is also shared. This is also shared between all the user. So this is the requirement which is needed to run applications. Okay. So here, I'm sorry. This is the thing. So now, guys, these are the things which is net, mount, PID, user. These are the type of namespace which is needed. How many times it get initialized? User get initialized multiple times, but PID, mount, and network get initialized only one time. Now the question is how this PID will get CPU and memory allocation. So who's doing it? So guys, this is doing it. So this will allow CPU, RAM, and network IO input output management to what? PIT. Okay. So C groups will do that. So if you are running any processes, any applications, so CPU will be given, awarded, it will take from the hardware. See here, it will take from the hardware and give it to all the processes, whatever you are running. Okay. Now, what is the capability? So guys, this user, it can be a root user. This user, it can be normal user. So guys, you know that root user has all the capabilities, whereas normal user has a no capability, less capability. So how do you differentiate? Who controls this? Suddenly you become a root. You are a user only. Root is also user, and Rajesh is also user. So how come root get more access? How come Rajesh get less access? Who controls it? From where it get controlled? So controlled by capabilities, which is again in kernel. So here it defined the root access and non-root access. So guys, guys, overall you need, if you want to run any applications, these are the things which is needed. You need capability, you need a C groups, you need one network, one mount, one PID, and one user namespace, so application can run. So is that answer your question?
Rajesh, can you please cover these capabilities once more?
Capabilities which is there in the kernel itself, namespace, C group, capability is there, which control the access of root and non-root users. Okay, who should be root, who should be non-root, what should be allowed to root, what should not be allowed to normal user. Everything is controlled by what? Capability. Where is that? Kernel inbuilt. Make sense?
Yes.
Okay. So now with that, guys, now we learn that how to run applications. But the question was, what is container? Okay. So what is container? So this, please remember, now we are going to travel in the history. Let's build a time machine. Okay. So we will travel in the history. Now 30 years from now, 15 years from now, and now. So guys, when we travel in the history, in the past, tell me earlier, when we wanted to run any applications, we were running applications on physical server. Don't you think so? Physical machine. Correct? Correct, guys?
Yeah.
Physical machines. So we were installing Photoshop, Flash, Acrobat, Tally, MS Office. So these are the applications we were installing. And used by who was the user? Who was the user? Directly, who was handling, who was running these applications?
Admin.
Admin, human, right? So earlier we were running that data, I mean, one applications, and that's my desktop, that's your desktop. We were running on a desktop, physical server, human. Then what has happened? Suddenly we got the internet. Internet evolutions we got it. Now, earlier we were running application in a physical machine, aka desktop, that's my desktop, or personal computing devices. Then we got the internet. And when we got the internet, then we started running applications not in desktop, but we started running, the trend started running applications in data center. Correct? No? We were starting running data center. Why? Because we wanted to consume the internet based applications. Correct? No? Guys?
Yeah.
So now think about it. See here, you only analyze this pattern because see, this is a physical machine, desktop, personal computing device. I can run my application till it allows the CPU and RAM. But when you run in a data center, think about it, small data center, there is a hardware layer, there is a kernel operating system, and then top of that you have all this namespace, all this stuff, okay, and then user. Okay, do you need a 3 user there? No. In the data center we need only 1 user and running applications. So think about it logically, we don't need a multiple user. Why we need a multiple user? Because in personal computing, desktop, there we don't need it. So you think about it, your peak time requirement in a data center for each machine is 20 GB RAM. Non-peak hours you need a 5 GB RAM. So when you configure the system and number of physical machines, then you configure with 20 GB or 5 GB, tell me. Which one will
20
configure?
GB.
Of course, very
20
simple
GB.
logic. 20 GB. Why? Because the peak hour is 20 GB. But you know one thing, if you look at the daily average requirement for running app, it's just 7 GB. Yeah, average. But you are setting up 20. That means how much wastage is happening on an average daily? 13 GB. Look at the waste. This is a waste. So more or less, when we are running application in a physical machine, 70%, yes, 70% of the resources, and when I say resources, that means CPU, RAM, storage, and operating system licensing cost were getting wasted. Why? Because we always set up the machines for the optimal level. So, but what has happened? So, people wanted, organization, company wanted to reduce their prices. They wanted to reduce their prices. So they decided to migrate from the physical machine to what? To what?
Virtual.
Yeah. So they decided we will not run application in a physical machine. We will run in virtual machine like a VMware. So now with the help of the internet, when then we got the internet, they wanted to reduce cost, saving time. improving efficiencies. So they wanted to reduce and they wanted to run in virtual machines. Can we check virtual machine? Do they provide the environment to run applications? Let's check it out. So this is the hardware layer. On top of it, this is the operating system, and then top of that hypervisor like a VMware. On top of that, you install one VM, 2 VM, 3 VM. This is having operating system, right? Each VM you have operating system, right? And then you create one network, one PID, one mount, and then you create one user and running app. This is what you do, right? Correct? Guys, this is what you do. One network, one PID, one mount, one user space app. One network, one mount, one user space, a PID and user space app. So now you are running one app, two app, three app. This is the virtual machine. This is the virtual model. Correct, right?
Yeah.
So now the question is, this is not helping us. Virtualization, we are running application in a virtualization model. It is not helping us. So can you find out the drawbacks here? Because earlier we were living on the internet. Earlier we were using internet. Now we are living on internet. How come? See here. When we got the internet Gmail first time, we got 100 MB space. Now how much you are getting? Gmail?
18 GB.
15 GB, right? You are getting 15 GB. That too also free of cost. See the 100 MB versus 15 GB. And are you paying for it? No. Are you paying for Facebook? No. Are you paying for the YouTube? No. Are you paying for any services which you are using online? No. Then the question is, how would they survive? Then you must be thinking they will make money from ads. But do you know they make money from the ads only if you click on the ads? So what is the CPC rate? So CPC rate is 1,000 people visit your website, out of which only 1 people click on the ads. That means you have to run website or application for 1,000 people, whereas your prospective client is only 1 person. So the organization again got into the mode of saving cost. For what? Running app. Saving time. For what? Running app. They wanted to implement CI/CD process and improve efficiency. Again, same thing. Saving cost, saving time, improving efficiency. So now they were running in the virtual machine. Then now what would they do? So they can save cost, save time, and improve efficiency. What they should do? So guys, can you tell me what is the drawbacks in this model? Drawbacks. What is the drawbacks in this model?
You have to size the underlying hardware of the building.
Something else?
Multiple operating systems.
Yes.
Multiple.
See guys,
Multiple OS.
in order to run 3 applications, you need to run 4 operating systems. 4. Now if you remember, this operating system also consume CPU, RAM, storage and licensing cost. So here you are running 3 applications in a data center. and you are wasting so much of money. This is a waste. 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 Can we do one thing? This is also heavyweight, not lightweight, heavyweight. This also consumes CPU, RAM, and licensing cost. So can we do one thing? Can we run all three applications in one operating system? Can we run? Let's draw a picture. So here, this is the hardware layer. On top of that, you have operating system come kernel. Okay, then it's a PID get initialized, network get initialized, process map get initialized. Okay, and then user 1, user 2. Let's talk about only 2 user right now. This user come from the user, I have already said. So can we run Apache here by user 1 and user 2? So Apache by default run on 80 port. Can I run 80 port again? Can I run?
Don't think so.
No.
You can run 80 port again.
80. Can you run 80 port again?
So this is a separate operating system or different operating
No,
system?
it's the same operating. See now, one operating system.
No, one process acquired 80, the other process will not take it.
So you have to run 81. Correct now? Here the PID for PID process ID is 50. Will you get the same PID to this Apache also?
No.
So it will become a 55 random anything. Now this Apache is writing up in a OPT location, OPT Apache. Now if this Apache will write in OPT Apache, then will be override, right? Overridden will happen. So that data integrity will be mismanaged. So you will write in 2. So tell me one thing here. This is just 2 applications. Now if you are running 80 and 81, will you be able to access load balance these 2 apps both? What is the load balancer rule? What is the load balancer rule?
It will redirect the traffics.
But rule. Different
load balance,
IP
right?
address, same
port.
Do we have a same port?
No.
The ports are different.
And do we have a different IP address for both application?
We have same IP address, right?
Same IP address.
Yes,
So
same
guys,
IP.
this load balancer will not work. Then how can you access www.google.com? Again, here think about it. There is a complexity also. OPT Apache and OPT Apache 1 or 2. So that means you are running thousands of applications. You give 1, 2, 3, 4, 5, 6, 7, like something like that. It's too much of headache and complexity, right? So what we do in this case? Again, you want to monitor the process ID. So 50 here, 55, changing the process ID. So what we do in this case? Yes, running here we were discussing about too much of operating system is a headache. But here, this is not.
Rajesh, I have
helping
one
us.
question.
Yeah.
Okay, even when we are running a app on this virtual environment, so there also we will have to reserve the RAM and disk space. Am I right?
Yes.
Okay. Then in that case also we won't be utilizing all those RAM at all the point of time. Our app will need maximum RAM at some point. At some point it will be below average. So that
What happens?
Go ahead. Go ahead.
What happens? Yeah, you are right. But what happens? You said here when we run applications in one environment, which is where is that? I missed that. I think I missed that. So when you set up a physical machine, then you go for the optimal requirement. Think about it. You have a
Correct.
highest usage is 20 GB, then you set
Mhm.
20 GB. But in a virtual machine, you don't set in a 20 GB, you set in a limited. And when you need a more CPU, more RAM, that means more load is there, you can add a more virtual machine immediately. Then physical machine you cannot add immediately, but virtual machine you can add it immediately. Don't you think so?
Mhm.
You can delete, you can add few virtual machines. This is called as auto scaling, scale up, scale down.
Mhm.
So you on demand you can do that. So still you will be saving that the slots of CPU and RAM for the flexibility, right? So here,
Mhm.
if you need a more load, you can add few machines. But here in that case, physical machine environment, you have to already acquired, you have to run it, and it will get wasted. You cannot reuse that infrastructure for something else. Getting
Mhm. Okay.
getting opens.
Yes, so server to application mapping is one to one in that case, but in this case, we could run multiple applications.
Right, yeah. You can add more, you can delete more, you can save cost, you reassign that resources for something else, reuse it, saving,
Mhm.
reducing the cost. A speed also you'll get it, no? Within a 5 minutes, your
Mhm.
application is running in the VM. But physical machine, you know
Mhm.
that set up a operating system, setting up this, that, procure the hardware.
Mhm.
So much of time will take, right?
Mhm. Okay,
Okay, so now
got
coming
it.
to the point here, the point is not that one. Point is, this is the you are able to run applications, but multiple application, but you have to change the port, you have to change the data path, your mount path, you have to change the PID, and that is not helping us in terms of load balancer. So what we do? So guys, do you remember in the kernel you have a mount, user, network, PID, all this. So what this guy did, this guy, Solomon Hikes. Look at this, look at him. This guy. So see what has happened. What has happened? Microsoft said, Microsoft and Linux said, I cannot change the architecture of operating system. Okay, I cannot change the architecture to support the data center. Why? Because they designed the operating system for personal computing. Understand that the computing architecture which you are using right now is basically designed 30 years in the past, 40 years in the past, but for not for the running data center app. At that time, data center concepts at all is was not there at all. So at that time, operating system designed for personal computing. So then they said, if I am designing operating system for the personal computing, what people will do with a more network, more mount, more PMAP? Only one PMAP is required, only one network is required, only one mount is required. But if I allow to create a multiple user, so maybe someone will be super user, someone will be normal user, their family, friends, college mates can work together. So they what they did, they allow Microsoft and Linux guy, they allow to create a multiple user, but only one PID, one mementi, one network namespace they created. Why? Because it was designed for personal computing. But because of this, in this model, lots of wastage is happening. Operating systems too many times. Then, but if you run in this model, it will not work. So what this guy did, very clever work he did, he changed the architecture of running applications. So what this guy did, Solomon Hikes, he said no problem. He said, if you will not change, no problem. What I will do that, I will write one tool. Okay. I will write one tool. Where? On top of this place. This tool will do what? This tool will read directly to the kernel. Take all this capability and I will create one user. I will create a user. How can you create a user? There's a user namespace is there. And this user will be managed by me, not by you. Yes, this user managed by me, not by operating system. See, this user and this user is managed by operating system here directly. But this user managed by this tool. And he said, I will assign, see, here each PID is shared between all the user. Each mount is shared between all the user. Each network is shared between all the user. So he said, I will give each user their own network, own mount, own PMAP. So let me create one more user. Own network, own mount, own PMAP. So now you tell me this has got their own mount and own network. So now this guy running Apache, can he run on 80 port? Can he run in 80 port? This guy is running Apache. Can he run 80 port? Yes, because this guy is referring this one. This guy is referring this one. Can he write Apache, OPT Apache? Yes, OPT Apache. Can he also write in OPT Apache? Yes, here. Can he run PID 50? 50? Yes. So did you understand that what is the architecture changes? So this guy said, operating system, if you don't do that, change the architecture, that's a genuine reason, because this operating system designed for personal computing, not for running application in data center. Then this guy said, no problem, I'll write a wrapper, one tool, which will create a user space only. But this time, this user will not get a shared network, share mount, share PMAP. He will get each user will get their own network, own mount, and own PMAP. So that way, this guy also run independently, this guy also run independently. And you know one thing? What we call this one? This we call it container. This we call it container. And what we call it this one? Docker. Did you understand that, guys? Everyone?
Yeah.
Yeah.
Any confusion now? What is a container? So guys, container is here. Look at this. It's a lightweight. See here, there is no operating system. How many operating system in this model? Only one. But still, this guy is behaving different. This guy is behaving different. So here, lightweight, standalone, complete and independent environment for running app. So this application, Apache, is not needed anything. They're not shared. So let me put it in a simple way, guys, for understanding purpose. You are also container. You have logged into your laptop right now. You are a container. I have logged into my laptop. I'm a container. But the problem with me and you each, we are a shared container. That means we are, let's say, all of you log into my laptop. We will be using same PMAP, same network, same mount. But these containers, which is created by Docker, have got their own network, own mount, own PMAP. Are you understanding this? Guys? Hello?
Yeah.
Yeah. So basically what I was trying to tell you, let's recap the things. Understand this. What is Docker? So it manages your container.
So
For what?
Rajesh, just a quick stop here. So is there a deep dive book or a page available for this container and Docker by these guys, Survan Hikes?
Go to the Docker website, no, and wiki and lots of tutorials you'll find. Look, deep dive into the kernel namespace. Okay, kernel namespace. You will understand this one. You get into this part, understanding. So Linux GNU documentation also you should read. Got it?
Sure.
Okay. So now the question was, what is Docker? So guys, Docker is a container management tool. Now what is a tool for saving? So here we are saving, no? See here. Here we are saving. We want to run applications. We are saving operating system cost, CPU, RAM, storage, and setup time. How much time it will take to create, improve efficiency? How much time it will take to create a new user? You tell me. How much time it takes? Second. VMs it take 5 minutes, but this it will take seconds. So here, saving time, cost also, efficiencies also. So now we understand what is a container. So in order to that, we understand how we run applications. We elaborated here, and then we got into this third timeline. So now we are using a running application in container, and this is container I am trying to teach you. So what is a container? So now the question is, what is a container? So container is a, understand that container is a technical language user namespace with one mount namespace with one P namespace with one network namespace. This container gets CPU and RAM allocation from C groups. Again, why not C groups? Why? This C groups is here. Look at this here. C groups is here. Here. So because this C groups can give you this RAM to here and CPU to here. So why this cannot give to here and here? Yes, it can give it, right? Because this is also user, but this is also user. And this user, whether it's a root user or non-root user, who will access it? Capability. It's in kernel. So capability. So here, and root and non-root, root and non-root, access by controlled by capability. Abilities in the kernel. Okay guys, so now this is the definition of container. With that guys, let me tell you here, this is Docker is a container platform, and now it is having two kind of release. One is a CE, which is called Community Edition, which I am teaching you, and here we have a EE also. You have Enterprise Edition, which includes SWAM and many other tools also, which I am not teaching you now. Okay, and here this is written in Go language. This is written in Go language. Okay, now by Solomon Hykes. Okay, I think first stable release has happened, if I'm not wrong. I have a very bad memory. So 2004, I guess, first release 2014, sorry, 2014. Okay, first release has happened. And so now this is a open source. This community edition is open source, by the way. Open source and free. This is paid. Understand that guys? Everyone?
I have one question.
Yes.
So, like the base OS is, say, like it is the Windows. So those containers, the apps that will run on those containers, those applications will be like Linux or Windows, or they can be different.
So by default, whatever I was talking about so far is for the Linux. But 2019 onwards, we have a Windows support also.
So like if base OS is Windows, so one container can run on Linux and other on Windows, like that?
Base operating you are getting confused here. One thing, understand this. Here you have a base operating system Windows. So this can create a user because user of Windows user. This can create Windows
Okay.
user. This is a Linux, so this can create Linux user. Linux user. This Linux user will get their own network mount and PMAP and run applications, run applications, run applications, run applications. Now this Windows support is there only from 2019 onwards. Before that, it was not allowed because Windows is a proprietary one. Linux is a open source.
Okay. Got it. Yeah, actually, I was comparing with VM. Like in VM, we can install like Windows as well
Huh.
as Linux.
Yeah. The window. That's another way. That's what we do. This is a host is your Linux. On top of that, you install hypervisor. On top of that, you
Yeah,
install Windows VM, and then you can run container. Host it can be
yeah.
Windows. You on top of that hypervisor. On top of that Linux, you can install containers. But
Oh,
this will have a Linux container. This will have a Windows container.
okay. Yeah, got it.
Okay, guys. Any other questions?
In this container approach, we don't need to specify the RAM that has to be allocated for the application.
You can specify, you can control that each user. In fact, here also nowadays we can in Windows also we do that. See, this is the process. You can customize, no, set priorities, high, normal, this, that, and all. You can assign that more CPU, more RAM. Here you see, this is the in Windows also you can this resource value memory percentage. Set this. Okay, so here also you can set this. That is set by C groups. If you want to set the CPU and RAM, C groups. So yes, each container you can set how much maximum you need, you can ask for it. Okay, but by default, if it's go, then based upon that, what is your needed or something. So you can control CPU, RAM, IO, input, output, and all. Each process you can control. Each process ID you can control that how much CPU this process ID can ask from the C groups. Okay. Got it, guys?
Yes.
More questions, guys? Okay, good. So now we have understood what is Docker and what is
Uh,
container. Now next,
Rajesh, I have one question. So we have a container, right? So how it talk to OS? So what is the unique thing which identify each user when we are talking from a container
see here,
to
what happened?
OS?
We have already discussed this one, how it talks. I said container is also user. You are giving a special treatment actually now. Container is also user. You and me, who is logged in, we are containers. But the problem with us is we are having shared resources, MENT, PMAP, network. But these containers, they get their own from the kernel. So the question should be how they manage. So Docker take the capability, all this information from the kernel, and Docker manage the state of the container, not operating system. Operating system do not manage these containers, but this user, normal user, which we are a normal user, which is shared user, which we is being managed by operating system. So that is the whole things I discussed to answer that question only. Did you
I
understand?
got it now. Yes.
I deep dive into that to just to understand how this container talk to the system. So in short, container managed by Docker. Docker take the capabilities from the kernel directly and empower each container with their own network mounts and PMAP and run the application independently and saving a cost. That was a problem. Here we were not able to run application because we were able to run application, but we were not able to access that application. Got it?
Yes, thank you.
Rajesh, just one thing. I might have missed something in the middle. So let's assume that one application requires a Windows OS and another one requires a Linux OS. So can we run both of them in the same Docker environment? So
No,
using this diagram, we can do it, right?
how can you run it? How can you run it? You tell me. So you have a, how can you run it? Both are kernel are different. No, again, Windows kernels are different. Linux kernels are different. So let's say your base machine is a Linux. Okay. Now you have a one hypervisor, install hypervisor, VMware, and then you have a Windows VM and we have a Linux VM. Here you can run the Windows container. Here you can run the Linux container. This way you can do that. But in one host, how can you run both the containers? Because kernels, you can have it only one, right?
Correct. So using this hypervisor approach, we can run it.
Yeah, we do that. No, we do that all the time.
Okay. All right.
Okay, guys. So now I think we have understood everything. Now, what are the next thing we are going to understand? So we are going to understand what
Rajesh,
the
this is
other
Hi.
container.
Rajesh, can you hear me?
Yeah, I can hear you.
Yeah, actually, going back to the previous question, why specifically we are asking that how can we run a container on a particular system?
Sorry, your question is not
My question was directed to the person who asked this question actually. The reason is this actually this is a very good question which you asked. My thought process there is container itself is leading us toward the serverless architecture.
No. What is your question?
Now my question was based on the previous question asked.
Can you repeat that question?
The question was asked was can we run a container Windows container on a can we run Windows container or a Linux container together on a particular operating system?
So this question, that's what I have been answering this question. Think logically. There is a two kernel in the whole world. Okay, Windows kernel, Linux kernel. Linux kernel can create Linux resources. Windows kernel can create Windows resources. I've been telling you very repetitively, this container is powered by kernel namespace, C groups and capability. So what you are saying, this is the Linux OS right now. So what you are saying, the Linux OS can only power the Linux capabilities, Linux mount, Linux PMAP, Linux network. So what you are saying, the kernel is Linux. How can you run Windows container? For that you need a Windows kernel, which is not in there in this. This is a very simple and straightforward answer.
No, you are right. So that I no doubt there. So from here, my point starts that with this features of containers and Dockers, actually we don't have to worry about which server it is running. We just worry about our containers.
No, we need to worry. We need to worry. No, you are talking about the serverless. Serverless not is a container at all. Okay, serverless concept itself is a different one. We'll talk about later if Kubernetes. We don't have that session, but that's a different topic here. Serverless means what? See, serverless means what? You do not worry about the infrastructure, runtime environment. You just send the function and it automatically run. That's called serverless. That means your method, you send that to the particular endpoint. They will take your code, they will run it, and they'll give you the response. That's all. That's a serverless. But somewhere it's running, right? So I'm talking about the runtime environment. So here, his question was, can we run Windows container on Linux? So I said you can run it, but you have to do some cheating. Here the cheating is you have a base machine, let's say Windows. We have a Windows. So you do one thing, install VMware. Then you have a Linux VM. Then you have a Linux container. Same way you can do push it with the Linux also.
No, I totally agree to the explanation actually. My question is still to the same point here, that maybe I can put it like this way. Why would need this architecture?
Why?
Why we would need any use case, that why we would have different container on a particular operating system?
Okay, yeah. Okay, this is the question. So see, understand this way. We are in the world of, we do not manage the physical machines directly. Okay, we do not manage physical machine directly. We have two kind of cloud, in fact 3 kind of cloud: public cloud like AWS and private cloud. Now private cloud, I'm talking about the private cloud. So private cloud, you have set it up on Linux. So you have Linux. Now when you set up a cloud, then you need a hypervisor like a VMware now. So Linux, you install hypervisor. Now this is the base. You have to have a one base, at least one base has to be there, Linux or whatever. And then top of that hypervisor. Now your client demands Windows machine or Linux machine. So both you can get it help with this hypervisor. So this way in the cloud, in fact AWS, they run on the Linux. But we can create a AWS and Windows machine also, right? AWS. So like that.
Yeah, so basically you're saying that if we are on our own private cloud, and then mostly we have to worry about it. But mostly if you're relying on the AWS, then
yeah,
they just provide it as
something like that. Yeah. Okay, guys. Now what is the next topic? So next topic is other container interface. What are the others? So Docker is alone in this? No, Docker is not alone. Docker is not alone. So if you go to here and you type container network interface, container interface, not network, sorry, interface. Okay, here I have mentioned all these things, though it's not up to date. I wrote last year only. I have to revisit, but again it will be applicable, not too many. So here you have a list of tools, which is interface, which will help you as a alternative Docker, Rocket Nets, CNI, Containerd, this, that, and all. Okay, so many tools are there. So now here these are the other network interface. Now next topic which I am going to cover is how to install Docker. That is a question. Then I am going to talk about Docker, how workflow of Docker. And then I'm going to talk about workflow, components of Docker. Before that, components of Docker. What are the components of Docker which we have to work with? Components of Docker. And then I'm going to talk about workflow of container. Yes, life cycle of container. So these are the questions I'm going to answer after this one break, and we'll get going. Any questions, guys?
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.